Hey everyone, welcome back. Um, Last time we left off with the introduction of the idea of the Earth having several layers, but we didn't really talk about what those layers were. Today we're going to focus on the interaction between tectonic plates, and we will get into that. So, the exercise that I'm going to have you do today via video is called Oreo tectonics. So last week I asked you to grab some Oreos. I recommended either mega stuff or double stuffed. The original and thins just don't have that much cream, so that makes this a little bit harder. I go with mega stuff. If for some reason you are really adamant about more cream on your Oreo, you could look for most stuffed, but that just seems like way too much sugar, and I don't want anyone to die from this assignment. So, last time we talked about the different layers in the Earth. The outermost layer is what we call the crust, and there are a lot of words here, so we will get into them. But right now, what I want you to focus on is the crust. So, this upper part that is all solid rock, that's what we live on. And then I want you to worry about the mantle, which is this uppermost part of semi-solid rock, and then down when it gets hotter closer to the core, it becomes more liquidy. Okay, so there's a crust, and then one, two, three, four layers here are the mantle. Okay, the crust is a rigid, solid layer of rock, and we have oceanic crust, which is the kind of crust that we have underneath the oceans. And we have continental crust, which is the kind of crust that we live on. We also mentioned that there was a difference in crust density last time, and we will talk a little bit about how the difference in density influences the types of plate interaction. So, without further ado, the way we're going to use the Oreos today, we're going to have an Oreo represent part of the Earth. So if you take out an Oreo and you look at it, the top cookie right here is going to represent our crust, and the white cream filling is going to represent our mantle. Now remember, they're both technically solids, but the crust, just like the cookie, is rigid and hard and it can be broken. The mantle is sort of an amorphous or shapeless solid, so it is still technically a solid, but it can move more like a liquid. Okay? Here's a diagram. It's pretty complicated about plate tectonics. So you can see here there are three types of plate boundaries all being shown. Here's a divergent plate boundary right here. Here are two types of convergent plate boundaries. This one is continental crust, sorry, over here, converging with oceanic crust. Over here we have oceanic crust converging with oceanic crust. And then something you may not notice is we have some plate movement along this line right here. And I know this picture is a little bit fuzzy, but this is what we call a transform plate boundary. Okay, it's basically where two parts of a plate or two parts of crust are moving against each other like this. Okay, and we'll do that with our cookies too. So now here's what I need you to do, since you can see me in the corner of your screen right now. I need you to take out your first Oreo. Now we're going to walk through this together. So we're going to try to not break our Oreos. First thing we're going to do is we're going to twist the Oreo just like you're unscrewing the cap of a bottle. And we're going to have this represent our continental crust, okay, or our crust. This is going to represent our mantle. Now, what we have to do is very carefully try and break this in half as best you can. Oh, that's my best one yet. I always mess this up. Just like I tried this earlier practicing. I had to go through it's like 7 Oreos to get this one right. Okay, and then I want you to place it on top just like this. See that? Now, this is going to be the tricky part. what I want you to do now, on the screen you see divergent plate boundary. It means there are two plates moving apart from each other. So that's what we're going to do with this cookie. Now, I want you to press down with the cookie, and I want you to move the two pieces of cookie away from each other. All right? So again, press down, move it away from each other. And you're going to feel some resistance from the cream or the mantle in this case. So here, you've just created a divergent plate boundary using an Oreo cookie. So what I want you to do now, and you're going to do this for each cookie you do, and you need to turn this in with your assignment, I want you to take a picture from this angle of the cookie so that I can see you've done the work, you've smushed this down, you've pushed the pieces of crust out from each other over the mantle. And I also want you to take a picture of the cookie from this angle so that I can see the two pieces of cookie have moved away from each other. If you have any questions, feel free to send me an email, okay? So that's good. So we've just done a divergent plate boundary. All right, so that's where we have mantle coming up and then two pieces of crust spreading out. Now we're going to do a convergent plate boundary. A convergent plate boundary is where we have subduction of one plate going underneath the other. So if you look on this diagram right here, you have the subducting plate, or the one that's going underneath one, and you have the overriding plate, the plate that's going over the other plate that's going down into the mantle. Okay? So this diagram has a nice arrow showing the movement of the plate that's going down. Okay, so now we're going to give this a shot. This one I had more trouble with last time. So we take an Oreo. We're going to do the same thing. Twist. Different. Okay. Twist and break. See, this is what I mean. It wasn't as good, but that's okay. Don't freak out. As long as there are two pieces that are like this, we'll be fine. So now I'm going to put them back. Now this one, I want us to start with them a little farther apart, okay? Now for this, apply pressure to the cookie. This one's going to be a little bit different. So press down some so the pieces don't fall off, and then push them in towards each other. Now, what we want to do here is we want to stress that there's a difference in density between these two pieces. So we're going to have this side go underneath this side. This side will go over this side, okay? So press down, and then you're going to push down into, push this side, the subducting plate down into the mantle, and then this side over. So it looks like that. Okay? Now, take a picture of this cookie from the top and from the side, and then turn that in as your convergent plate boundary cookie. One more, and then you get to eat the cookies. So this one, we're going to do transform plate boundary. Now this is where we have two plates that are not moving apart or colliding with each other. They're moving against each other like this. Okay? So we're going to do the same thing. This cookie's messy. Twist. Break in half. Wow, that was bad. They don't make these like they used to. All right, now going to move them along each other just like this. See how they're not colliding, they're not moving away, they're just moving against each other. So this one You can still take it from this angle, the picture, but this is the more important angle because this is, you can see a better picture of the relationship between these two plates now. Okay, so that is your transform plate boundary. Don't forget to submit a picture of this with your assignment. Okay, so that's it for this assignment right now. It was quick and easy. Next time when we meet up, we're going to talk a lot more about how plate tectonics works. But it's good for you to model these three types of plate boundaries. So thanks for watching and be on the lookout for the next assignment.